Every week, I get some version of the exact same message. Everything was working fine. I rebooted the server, and now my bot or my client won't reconnect to Telegram. 9 times out of 10, Telegram did nothing wrong at all. The reboot took something down with it that nobody was watching, and the client just quietly failed to come back up on its own. It is one of the most common tickets we see, and it is also one of the easiest to fix once you understand what actually happens during a reboot. I run managed Telegram hosting and proxy infrastructure for a living, so I see this exact failure on other people's boxes all the time, not just my own. This is not a Telegram-specific quirk either. It is what happens to any long-lived network service running on a machine that gets restarted. And once you see the pattern, you will recognize it everywhere, not just with Telegram. So let's actually walk through what a Telegram connection is, because that is where the confusion starts. A Telegram client, whether that is the desktop app, a user bot script, or something you built yourself on top of mtproto, holds a persistent TCP connection open to one of Telegram's data centers. That connection carries an authenticated session tied to an auth key that gets generated once when you log in, and that key gets stored locally in a session file, or sometimes kept in memory and written to disk every so often. Here's the part people usually get wrong. The connection itself is not fragile. mtproto clients are built from the ground up to expect drops, because mobile networks flat constantly and nobody wants to re-log in every time they walk into a lift. Every reasonable client library ships with reconnect logic and backoff built right in. If your laptop's Wi-Fi cuts out for 10 seconds while you're on the train, Telegram desktop just quietly reconnects and you never even notice it happened. The server reboot is a completely different kind of event, and this is the thing to really sit with. It is not a network blip that the client can just ride out, because the process that was holding the connection does not exist anymore. It got killed. So the real question is not will the client reconnect, because reconnect logic was never the problem. The real question is, will anything actually start the client again, and will it start in an environment that is genuinely ready for it? It's time picture it like this. You've got a user bot sitting on a box, quietly polling messages, running for weeks without a hiccup. Someone patches the kernel, or the host does routine maintenance, and the box comes back online 60 seconds later. From the outside, everything looks fine. The box responds to ping, SSH works, you can log in, but the actual process that was holding your Telegram session is gone. And unless something specifically restarts it, it just stays gone until you notice and start it by hand again. When someone tells me their setup does not survive reboots, it is almost always one of 3 problems, and none of them are actually about the connection layer at all. Let's go through each one, because once you know the 3, you can check your own box against them in about 5 minutes. The first one, and the most common by far, is that the process was never told to restart in the first place. If you started your client by hand, SSH into the box, ran your script directly in a terminal, and just left it running, a reboot kills that process and nothing on earth is going to bring it back. This has nothing to do with Telegram specifically. Any process started this way behaves exactly the same, whether it is a Telegram bot or a web server or anything else. The fix here is process supervision, and on a Linux VPS, that means a proper systemd unit, not a background shell job with an ampersand at the end of it. You write a small unit file that describes your service, point it at the script you want to run, and hand control of it over to systemd instead of your own terminal session. It takes maybe 10 minutes to set up the first time, and it solves this entire category of problem permanently. 2 settings in that unit file matter more than everything else combined. The first is telling systemd not to start your process until the network is actually online and usable, not just until the network service has technically been enabled. The second is telling systemd to restart the process automatically if it ever crashes, with a short delay before it tries again. Get those 2 things right, and the process never told to restart problem simply stops existing. The second problem is sneakier, and it is one that only shows up on a cold boot, which is exactly why it confuses people so much. Some distributions bring the network up in stages, and there is an earlier stage that looks like the network is ready when DNS resolution has not actually finished yet. If your service starts in that window and tries to resolve Telegram's data center host name before DNS can actually answer, You get a connection failure that looks identical to a broken client, except it is really just a timing problem. This is exactly why that short restart delay I mentioned a moment ago matters so much. If the very first attempt fails because the network genuinely was not ready yet, that built-in delay, something like 5 seconds, gives the network stack a few extra moments to finish coming up before the second attempt fires. Without that delay, you can end up in a tight crash loop that never actually succeeds, even though the network would have been fine 2 seconds later. Means as The third problem, and this one catches even experienced people off guard, is that firewall rules did not come back after the reboot. If you're running your own mtproto proxy, or you've hardened the box with rules for the specific ports Telegram uses, remember that raw firewall rules typically live in memory only. They do not persist across a reboot on their own, unless something is specifically configured to reload them at boot time. This one trips people up constantly, because the rules were correct, they were tested, they were working right up until the moment of the reboot. Then the box comes back with a clean, empty rule set, or whatever the distribution's default happens to be, and suddenly the proxy port is unreachable from outside, even though the proxy process itself is running perfectly fine on the inside. From the outside, it looks exactly like the proxy died, when actually the proxy is fine and the door to it just got locked. The fix depends on what you're running. On Debian-based systems, the usual answer is a small package called iptables persistent, which saves your current rule set and reloads it automatically on every boot. On systems using nftables, the equivalent is making sure the nftables service itself is enabled and configured to load your saved configuration file at startup. Either way, do not just trust that it worked yesterday. Reboot the box on purpose on a day when it does not matter if something breaks, and check the rule set again from a genuinely cold boot. Now let's talk about proxies specifically, because there is a fourth wrinkle here that is worth calling out on its own. If you're running a personal empty proxy instance, the proxy link you hand out or configure in a client has the server's IP address and port baked directly into it. That is completely fine as long as the server's public IP never changes. On a proper VPS with a static allocation, it usually won't. But on some smaller providers or on a home connection sitting behind DHP, a reboot can trigger a brand new IP lease, and that silently invalidates every single proxy link you ever built around the old address. Nobody gets an error message. The links just quietly stop working, and you find out when someone messages you asking why the proxy suddenly refuses to connect. If your setup has any dynamic IP risk at all, the practical fix is a DNS name with a short TTL pointed at the box, updated automatically whenever the IP changes, rather than handing out raw IP addresses in your proxy links. There is one more piece to this that people rarely think about, and it is about session files and shutdown order, not startup order. The auth key and session state for a client library get written to a session file on disk, and most libraries only write to that file periodically, not on every single message that comes through. That means an ungraceful kill, something like a hard power cut, or a reboot that does not give the process time to shut down cleanly, can catch that file mid-write. A corrupted session file is not just an inconvenience that costs you a reconnect. It can force a full re-authentication on that account. And for account safety reasons, that is exactly the kind of event you want to avoid triggering unnecessarily. Repeated forced logins on the same account raise its risk profile with Telegram's anti-abuse systems, especially when those logins happen to come from different IP addresses each time, which is exactly what happens if your proxy IP has been quietly drifting too. Two things cut this risk down significantly. Give the process an actual chance to shut down cleanly, instead of just yanking power. System sends a polite termination signal before it sends a forceful kill signal with a timeout you can configure yourself. So a graceful reboot generally gives a well-behaved client enough time to flush its session file properly. And if you're running the client inside a container, double check that the container stop signal is actually forwarded through to the client process and is not being silently swallowed by some init shim in between that never passes it along. Put all of that together, and here is what a setup that actually survives a reboot looks like in practice. A system div unit with automatic restart enabled, a dependency on the network genuinely being online rather than just enabled, firewall rules that get persisted and reloaded through the proper mechanism for your distribution, and a session file sitting on a disk that mounts before the service even tries to start, which matters a lot more than it sounds like it should if you're using a separate data volume for anything. None of this is Telegram-specific configuration. It is just standard Linux service hygiene, applied to a service that happens to be a Telegram client. And I want to be honest about what none of this actually fixes, because solid process supervision only gets your client running again after a reboot. Nothing more. It does not protect the underlying account from the normal consequences of unstable infrastructure like flood weights triggered by reconnecting too aggressively, or extra scrutiny triggered by logging in from a brand new IP after a proxy's address quietly changed underneath you. Reliability and account safety are related, but they are genuinely separate problems, and a setup that is good at one of them is not automatically good at the other. If you're watching this and weighing whether to keep wrestling with systemd units and firewall persistence yourself, or hand the infrastructure side over to someone who does this full-time, that is genuinely the gap I built this business to close. We run managed Telegram hosting and proxy infrastructure on dedicated SG hardware, and the full article that goes with this video, with every config detail I just walked through laid out in full, is over at telegramvault.org. That's it for this one. If this kind of practical infrastructure breakdown is useful to you, go ahead and subscribe for more.